I'm going to talk about the rules, the truth-preserving rules that we use in proofs relating to the conjunction. So remember the truth function for conjunction is that the conjunction is true only when both conjuncts are true, and otherwise it's false. So what do we know when we know a conjunction is true? We know that its left conjunct is true, and we know that its right conjunct is true. And so the rule ampersand elimination allows us to derive, to prove from a conjunction to prove its left conjunct, or from a conjunction to prove its right conjunct. And that will always be truth preserving, because if the conjunction is true, we know we're on the top line, right? We know we're on the line where both conjuncts are true. So knowing a conjunction is true means you know its left conjunct is true, and you know its right conjunct is true. So you could never go from true to false by proving the left conjunct of a conjunction. Because if the conjunction is true, then so is its left conjunct. And if the conjunction is true, then so is its right conjunct. So it will always be truth preserving to prove from a conjunction either of its conjuncts. Proving a conjunction will require you to know that both the left conjunct is true and the right conjunct is true. And that is a rule that we call ampersand introduction. And that allows you to prove from any two sentences that you already have proved a conjunction having those two sentences as the conjuncts. And because the conjunction is symmetrical, it doesn't matter if you flip the conjuncts of a conjunction, the truth value remains the same. So from P and Q, you can put them together, making P the left conjunct and Q the right one. You get both P and Q. Or from P and Q, you can put them together with P as the right conjunct and Q as the left, and you get both Q and P. And again, this will always be truth preserving, because if P is true and Q is true, then both P and Q is true. And also if P is Q and Q is true, then both Q and P is true. So these are truth preserving rules. Ampersand elimination you apply to conjunctions. Ampersand introduction you use to prove conjunction. So suppose we had a proof. We have two conjunctions as our premises. The first is, so we assume our premises, and we these are the line numbers. These are this is the assumption set. I uploaded a Word document to the Brightspace page which goes through the structure of the proof, so you might want to look at that. But this is the same for all proofs that we do. We number the lines, we keep track of the assumptions on this side, and over here we write the rule by which the sentence on that line is proved. Well, in this case it's not proved, it's just assumed. Okay. And suppose we want to prove Q and S on assumptions 1 and 2. So we have to fill in this gap. Here are our two premises, here's our conclusion. Well, we just take Q from 1. So that will be 1 ampersand elimination, right? From a conjunction, you can take the right conjunct. So we here have taken the right conjunct from 1, and because we only used the sentence on line 1, and that's an assumption, the assumption set is just the assumption set of that line 1. And then we can take S, the right conjunct of 2, from 2 by ampersand elimination, and the assumption set here will be 2 because line 2 is an assumption, and so the assumption set is 2. And then we put them together using the other rule, ampersand introduction, and this says here 3, 4, ampersand introduction, 3 rests upon 1, 4 rests upon 2, so our assumption set is 1 and 2. So this is a proof. It's a proof of the sequent right? So what we've done here is assume the premises are true, and then in a series of truth-preserving steps, we've got to the conclusion of the sequent using these truth-preserving rules, ampersand elimination, take the right conjunct from 1, take the right conjunct from 2, and then stick them together to make the conjunction both Q and S. And this proves the validity of the sequent because it proves that from the assumption of the truth of the premises, you can get to the truth of the conclusion in a series of truth-preserving steps. Now, do we actually know if these sentences are true or not? No. What we have proved is not that this sentence Q and S is true. What we have proved is if the sentence on 1 is true and the sentence on 2 is true, then this sentence on 5 must be true. And every line in our proof system actually represents a valid sequent in this way. Assume that the sentence on 1 is true, that's P and Q. Assume that the sentence on 2 is true, that's R and S. Then you must accept the truth of this sentence Q and S because it's been reached from those assumptions, and just those assumptions, only assumptions 1 and 2. It's been reached in a series of truth-preserving steps. So that's 2 of the rules. The rule that allows us to take a conjunct from a conjunction, and the rule that allows us to build up a conjunction from 2 sentences. So one thing to notice here is that ampersand elimination is what I call a one-line rule. From one line containing a conjunction, you can get the right conjunct or the left conjunct. Here, from one line, line 2, you can get S because it's the right conjunct. But ampersand introduction is a 2-line rule. You take a sentence from line 3, Q, and a separate sentence from line 4, S, and you put them together. So some of our rules are 1-line rules, some of our rules are 2-line rules, and then there's another kind of rule, an assumption rule, which we'll get to. So you assume your premises, you take truth-preserving steps to your conclusion. That is a proof of the validity of the sequent. So that's ampersand elimination and ampersand introduction. And these are simple rules because, of course, the conjunction contains a lot of information. It tells you that both its conjuncts are true. So ampersand elimination is truth-preserving because for a conjunction to be true, both its conjuncts must be true. If you think about the disjunction, you'll realize things can't be the same with the disjunction. The disjunction is true just so long as at least one of the disjuncts is true, right? So whereas with the conjunction, you can go from the truth of the conjunction to the truth of the left conjunct, or to the truth of the right conjunct. You clearly can't do that here, because knowing that either P or Q is true doesn't tell you whether you're on the top line, where they're both true, or the second line where the left disjunct's true but the right one is false, or the third line where the left disjunct's false and the right one is true. So you cannot go from either P or Q to P, truth preservingly. And you cannot go from either P or Q to Q, truth preservingly. So the rule for the disjunction can't be like the rule for conjunction. The conjunction, if true, both its conjuncts must be true. But the disjunction, if true, all we know is at least one disjunct must be true, and we don't know which. If only one of them is true, we don't know which. Because there are three ways to make the disjunction true, it contains much less information. And so we will have to supplement the information that we have in the disjunction. And that's what we do in the rule that's called wedge elimination, and I'll talk about that next time.